Imagine lying outside on a quiet evening when the stars are sharp enough to make you forget the ground beneath your feet. You let your mind drift and begin to wonder about the worlds that circle those distant stars. For most of human history, we had no proof that such worlds even existed. The planets we knew were the ones close to home, the small family that orbits our sun. They seemed like enough. Mercury with its scorched face, Venus shrouded in cloud, Earth with its oceans, Mars with its rusty deserts, and then the giants farther out, all circling in predictable order. It felt stable, familiar, complete. When astronomers finally learned to look beyond, they expected to find similar families elsewhere, variations on the same theme. Instead, they discovered planets that broke the rules, planets that, by all logic, should not exist, and yet they do. The discovery of exoplanets began only a generation ago. In the early 1990s, astronomers announced the first confirmed detections of planets around other stars. These early finds were not gentle Earth twins. They were enormous giants, larger than Jupiter, circling close to their suns on orbits that lasted only a few days. They were blisteringly hot, swollen by the radiation of their stars. We now call them hot Jupiters. According to our theories at the time, such planets should not have been possible. Gas giants were supposed to form far from their stars, in the cold outer regions of planetary systems, where ice and gas could accumulate. Yet there they were, huddled close to their suns, defying the models. Scientists eventually proposed that they must have migrated inward after forming, pulled by interactions with the disks of dust and gas that once surrounded their stars, or nudged by the gravity of other planets. However it happened, hot Jupiters were the first sign that the universe is not bound by our expectations. Other planets revealed even stranger paths. In our solar system, the orbits are nearly circular, giving us stable climates and predictable seasons. Yet many exoplanets travel on stretched, eccentric tracks. They rush close to their stars, heating violently, then drift far out into deep cold before swinging back again. Such orbits should be unstable over billions of years. Yet we find worlds living this way, enduring wild extremes of temperature and light. Some are gas giants, others are rocky. All of them seem like cosmic experiments that nature decided to keep. Then came the discovery of circumbinary planets, worlds that orbit two stars at once. For a long time, it was thought that the tug of two suns would make such orbits too chaotic to last. But telescopes like Kepler revealed otherwise. Some of these planets move in graceful paths that encircle both stars, basking in double sunrises and double sunsets. Their skies would never look like ours. They would shift from one star, casting long shadows, to two stars shining together, filling the landscape with overlapping light. What once seemed impossible turned out to be not only possible, but common. Perhaps most haunting are the rogue planets, worlds that wander without a star. They drift through the galaxy like lonely travelers, wrapped in cold and darkness. Some were likely born around stars and then flung away by gravitational encounters. Others might have formed on their own, directly from clouds of gas, more like failed stars than true planets. However they began, they exist in numbers that may be greater than the stars themselves. Imagine a galaxy where the true population of planets is not the neat families circling suns, but billions of solitary wanderers, silent and invisible, their surfaces frozen, their cores still faintly warm from their violent births. There are also planets that astonish with their densities. Some are as massive as Jupiter, yet no bigger than Earth, suggesting they are made almost entirely of heavy elements like iron. Others are the opposite, swollen giants with densities so low that they resemble cotton candy. They are so puffed up by the heat of their stars that their atmospheres stretch into space, fragile and strange. These extremes challenge our theories. How does nature compress a giant into the size of a small world? how does it inflate a planet until it almost floats? Each new example forces scientists to revise models of how matter behaves under pressure and heat. One planet orbits a pulsar, the remnant of a star that exploded as a supernova. The blast should have obliterated anything nearby, yet somehow a planet remains, circling a collapsed sun that spins and flashes with deadly beams of radiation. Another orbits in a cluster of stars so dense that gravitational tugs should have stripped it away long ago. These survivors tell us that planets are not fragile decorations, but resilient companions. They cling to their orbits through chaos and violence, and they remind us that survival often takes stranger forms than we expect. The Kepler Telescope deepened the mystery by showing us just how many strange systems exist. It stared at a single patch of sky for years and found thousands of worlds. Some systems are packed with multiple planets circling closer to their stars than Mercury does to ours. They are locked into resonances, their orbits timed to each other like notes in a repeating song. Others tilt at odd angles, spinning and circling in ways that defy the neat disk we once thought was the rule. Among them are super-Earths, larger than our planet but smaller than Neptune. These seem to be the most common type of planet in the galaxy, yet our solar system has none. Why we lack them is still a mystery. Some planets reveal atmospheres with weather so exotic it borders on the fantastic. There are hot Jupiters where it rains molten glass that blows sideways in winds faster than sound. There are worlds covered in oceans so deep that their floors are crushed into exotic ice by the weight of water. There are planets where the day side is locked, facing the star in permanent daylight, while the night side remains in endless cold, with the twilight winds howling between. Each discovery reads like a fragment of myth, yet each one is real, measured in spectra and light curves. One famous example is HD 239455b, nicknamed Osiris. It was the first exoplanet observed to have an atmosphere escaping into space. Streams of gas flow away from it, forming a tail like that of a comet. The heat of its star is literally stripping it apart. Another is 55 Cancri e, a planet thought to be rich in carbon, which under immense pressure could exist in the form of diamond. Imagine a world where mountains and crust are laced with gemstone, a glittering planet that shines not because of its star, but because of its own impossible chemistry. Others are equally bizarre. Take WASP 12b, a hot Jupiter so close to its star that it is being distorted into an egg shape, its material stretched by tides. Or Kepler 70b, a planet smaller than Earth, but hot enough to melt steel, orbiting a star that once expanded into a red giant. Somehow it survived, clinging close in an orbit that skims its sun's surface. There is GJ 1214b, a water world with an atmosphere so thick and hot it may be made of supercritical steam, a state of matter that is neither liquid nor gas. These are not just curiosities. They are reminders that the menu of possibilities is wider than our imagination. Each of these discoveries has forced scientists to rethink what a planet can be. For centuries, we imagined our solar system as a model for the universe. Now, it seems more like an outlier. Our wide spacing, our nearly circular orbits, our lack of super-Earths, all make us unusual. That does not mean we are unique, only that we are one possibility among many. The phrase planets that should not exist does not mean they truly defy physics. It means they defy our expectations, and expectations can always be rewritten. As you picture these strange worlds, let your mind wander. Think of a double sunset on a circumbinary planet, shadows stretching in two directions at once. Think of a rogue planet drifting in silence, its skies filled only with the faint glow of distant stars. Think of a hot Jupiter so close to its sun that a year is just 3 days, its clouds boiling in endless storms. Think of a diamond world glittering in the dark, its very crust transformed by pressure into crystal. These images may seem like dreams, but they are stitched from data and mathematics. from light carefully measured and patiently analyzed. The search continues with new instruments. The James Webb Space Telescope is beginning to probe the atmospheres of distant worlds, measuring the fingerprints of molecules in their skies. Ground-based observatories use giant mirrors to push detection limits further. Planned missions will search for Earth-sized planets in the habitable zones of stars like our own. We may soon find not only impossible worlds, but familiar ones, blue and green spheres, that echo our home. Until then, the strangeness is enough, and the list of candidates grows longer. TESS, the Transiting Exoplanet Survey satellite, has already added thousands more. CHEOPS in Europe is refining their measurements. Soon, the Plato mission will search for worlds where life might take hold. Each step adds to the atlas of impossibility. Some of these planets may host exotic chemistry. Some may hide moons with their own surprises. Some may hold atmospheres thick enough to brew weather patterns we cannot even picture. The more we look, the more we realize the catalog of planets that should not exist is not a short appendix, but the main story. The lesson of these discoveries is humility. Each time we think we understand the limits of nature, we are surprised. Each time we think we have the pattern, the universe reveals a variation. It is a reminder that science is not a book of settled answers, but a conversation with reality, one that deepens with every question. For those listening at night, this is a comfort. It means that wonder is renewable. There will always be more to learn, more to imagine, more to dream about under the stars. Let your thoughts settle on the idea of planets that should not exist. They may be inhospitable to life as we know it, but they exist as proof that possibility is wider than certainty. They endure in violent orbits, in impossible densities, in solitude between stars. They remind us that survival and being are not limited to familiar forms. They remind us that the universe is a place where imagination can find endless nourishment. As your breathing slows, picture the galaxy filled not only with stars, but with these worlds. Some orbit in neat chains. Some drift alone. Some are scorched. Some are frozen. Some glisten with diamond crusts. Some wear tails of vapor like veils. All of them are real, and all of them make the night sky larger. The phrase "they should not exist" is less about them and more about us. It measures the gap between what we thought we knew and what nature has shown us. In that gap, there is room to rest. So tonight, as you drift towards sleep, let the thought of impossible planets carry you. Imagine the twin sunrises of a circumbinary dawn. Imagine the eternal night of a rogue planet drifting forever. Imagine winds that carry glass across the skies of a hot Jupiter. Imagine oceans so deep that the water itself is crushed into new forms. The universe holds these places without effort. They exist whether we see them or not. Our task is simply to wonder, and in wondering, we find calm. Planets that should not exist remind us that life is full of surprises, that certainty is always temporary, and that beauty is often found in the unexpected. But the story doesn't stop there. As astronomers catalog these strange worlds, even language begins to fail. When we say a planet rains glass, we picture shards falling from the sky. In truth, the winds may drive them sideways, circling endlessly in glittering streams. When we speak of a planet made of carbon so dense it could be a diamond, we imagine jewels. But what exists is vaster, an entire world where pressure rewrites chemistry. Even imagination struggles to keep up. Some planets blur the line between star and planet. Gas giants so heavy, they almost ignite into nuclear fire. They hover at the edge of classification, neither one thing nor the other. These twilight bodies remind us that our categories, planet, star, moon, are conveniences, not truths. The universe is under no obligation to fit our boxes. And then there are water worlds. Not the mythic ocean planets of cinema, but real candidates. Super-Earths drowned in seas hundreds of kilometers deep. On such worlds, the pressure at the bottom would crush anything we know, yet hidden chemistry might still thrive. To float above an endless ocean, knowing no land will ever rise, is to feel both wonder and unease. It asks us to question what habitable really means. Even our solar system holds reminders of impossibility. Venus spins backwards, its surface hot enough to melt lead, yet cloaked in clouds that once fooled astronomers into thinking it was paradise. Neptune radiates more heat than it receives from the sun, as though something inside still stirs. Uranus rolls on its side, poles where its equator should be. Even the familiar is strange when studied closely. Every discovery adds to a quiet lesson. The universe is wilder than we thought. Planets are not rare exceptions, but inevitable outcomes. If stars form, planets follow. If planets form, some will bend rules, some will break them, and some will erase the rules entirely. The catalog will only grow stranger as our telescopes sharpen. For those listening tonight, imagine this: drifting beyond the solar system, beyond the stars you know, into the dark where only instruments can see. Out there, circling quietly, are worlds with sunsets no eye has yet watched, storms no ear has yet heard. They exist without witness until we stumble across them. They remind us the universe is not waiting to be seen. It simply is, vast and indifferent, and our awareness is the exception. Yet in that indifference lies comfort. To know that planets form in ways that should be impossible, to know that rules bend and boundaries blur, is to glimpse a truth about life itself. The improbable does not mean the impossible. And as long as the universe continues to surprise us, there will always be more to wonder at, more to learn, more to imagine. So tonight, as your breath slows and your eyes close, carry with you the thought of those worlds that should not exist, but do. Carry with you the quiet truth that impossibility is only another kind of invitation to dream wider, to listen closer, to remain open to the unknown.